In this example project, I've got a bunch of moving parts that don't do anything, and I'm going to use code to join them all together. The point of this is to show you some of the techniques that you've learned in this module in context, so I'm going to use those methods to put this game together. If you want to, you can follow along. You'll find the assets for this project linked below. However, I don't really want you to do that. What I'd like for you to try and do instead is to try and think about each problem that I'm going to solve. Think about how you think you would approach it, and if you know why I'm doing what I'm doing. So the point of this course is that I want you to understand what tools are available to you and when you would use them. So if you're following along and you find yourself starting to think ahead, like you know what I'm about to say, then that's good. You're ready for the next module. If not, don't worry. If there's something you don't understand, just send me a message in the course Discord server and I'll help you. So in this game, the player can fly around to avoid asteroids. They can also fire a weapon to destroy them, scoring points. If an asteroid touches them, they die and they lose a life. Lose 3 lives and the game is over. And the aim is to get as many points as you can. Or if you're playing against someone else, more points than them once both players have lost all their lives. How am I going to do that? I'm going to make a game manager that's going to create all of the objects in the game and keep track of the score. It will create each player with their own player number, which will allow other systems to know which player is which. The player, the asteroids, and the projectiles will all be prefab objects so that the game manager can copy them into the scene. And I'll be making basic object pools to reuse frequently created objects without having to constantly instantiate them. I'll be using physics to move the player, and I'll be using physics to move the asteroids, but not the projectiles, which I'll move using their transforms. For input, I'm using the new input system. So this works by automatically assigning input devices. I've got 2 controllers here, to player objects that have player input components attached to them. So this means I can create 2 objects that are players, and it will know that one of those is assigned to one controller and one of those is assigned to another controller. To remember which is which, the player input components can't be disabled. So that's why there is a player container here with the player input component. That broadcasts messages down to the child objects. So normally the default setting is send messages, which would just send these input messages on the same object. I've got it set to broadcast so that it does it to all of the systems that I'm going to put on this player object. That is managed by the player input manager, and all this does is keep track of how many players there are in the game and which controls are assigned to which input component. The point of this is so that it's not constantly guessing what's connected to what, so that when one player dies and comes back again, the controls don't swap because it's automatically switched them, which I did have happen a couple of times when I was preparing this example. So that's what I'm doing with inputs. Then at the end of the game, when all the lives are gone, all I want to do is show a message to say who won if they're playing 2-player, and then just restart the game. And that's pretty much it. So in case you need to see how I go from downloading the source files for this project to getting it exactly how I've got it in the demonstrations, I'm just going to run through those steps now. Not all of you will need to do this. If you're new to Unity, you might find it useful. If you're not sure sort of what I've done to set up the scene, you might find it useful. If that kind of thing is already obvious to you, you don't need to take this lesson. You can skip to the first one. Like I say in the next lesson, this module is not about you necessarily following along. There is no expectation that you should download these files and copy the steps I do. The point of this is to add context to the lessons that you've already taken. However, they are available for you to look around, to poke through and to experiment with, and to follow along if that's useful to you. In which case, if you want to be able to get the scene looking exactly as I've got it in the video, I'm going to go through those steps from scratch right now. So I'm actually going to use a higher version of Unity. I want to create as much friction in this as possible. So I'm going to use Unity 6, which is a beta version and higher than the one this project was made in. So just in case there's any problems, I can solve them, and then you can see. I'm going to use 2D built-in render pipeline. So the point of picking 2D is if you pick 3D, the sprite package will not be automatically installed. It used to be, but it was not if you pick 3D. You can just install it afterwards in the package manager, but choosing this, you'll get that already installed. So I'm going to do I'm not going to connect it to Unity Cloud, and I'm going to select my organization and create the project. Okay, so we're into Unity now, and I've got the Unity package. So what I'm going to do is I'm going to go to Assets, Import Package, Custom Package, and then I'm going to go to the desktop and select this package. It's going to ask what I want to import. I will take all of that, thank you. And then those files are in. Now, I can open the scene now, however, there are a couple more packages I'm going to install first so that it doesn't break. So I need to go to the package manager. I'm going to select the Unity registry. I'm going to select the input package. There we go. Select install. It's going to install the input package. Now what it's going to do next is it's going to ask me if I want to enable it. So this is what this is. So the original input manager will be enabled by default if this isn't installed. You can run both, or you can restart it and enable the new input system, which is what I'm going to do now. So I'm just going to click yes. If you don't do that, then you can go into your project settings and do it later. Okay, so the input system is installed now, and the other one I'm going to install is the post-processing. So install that. And this just enables some of the visual effects that I had in the example in the video, and it will just prevent a couple of scripts from saying that they're missing. Okay, so that's now done. I can exit that. So now I can actually open the scene. So if I go into the scenes folder, sample scene is what's automatically created when you create the project. So this is empty, there's nothing in there. Example scene is the one that comes with the package. So I'm going to double click that. And I'm just going to maximize this. And let's just see if anything breaks when I run it. No errors. Okay, so this is working in that it doesn't do anything, but doesn't create any errors. Okay, so let's talk a bit about this project and what I've done to set it up. So first of all, let's go to the player object. Where is the player object? So the first thing that you might notice about the player object is that it's inside a player container. Now, this is for input reasons. So the player input component, which sits on this container, it identifies an object as a player. So as far as the input system is concerned, this is one player. You duplicate it, you have two players. And the reason it needs to know this is so it can assign control devices on a per player basis. Now, for that to work, for the player to still be seen and recognized, it can't be turned off. If it's turned off, it would assume that that player has left the game and then reassign a new controller to that player. So what you get if you're using the system of kind of turning objects on and off to disable them after the player has died, the problem you can run into is where the other player's controller is then assigned to the other player and they swap round. To avoid this, you just never turn off the input component, and then that way, It's just this player object that gets turned on and off when the player dies, and the input system still knows that this player is assigned to a particular controller. Now, how does the input system know what a controller is? Well, this comes down to the input actions asset. So if I go into input actions, now when you make a new Unity 6 project, I believe you get these set up for you automatically. Or at least I've seen this get set up for you automatically at some point. I set this up though, so it's a fairly basic thing. Basically, it has two control schemes, a gamepad and a keyboard. So a gamepad just has turn, move, and fire with the right trigger, the left stick up, and the right stick left and right. And the keyboard is space, W, and A and D. And that's all it does, really. The reason I added keyboard was I had two controllers connected to this when I set up the example, and that's what I was using, but you might not. You might have one controller or one controller and a keyboard, and that way you can recreate the two-player version of this without needing two controllers. So that's where these actions come from, and they call these actions as functions. So turn, move, and fire, no matter which control scheme you're using, become on turn, on move, and on fire. So if I go back to the player container, you can see here, will broadcast messages to game object, on device lost, on device regained. These are just system messages for the input system. On controls changed, and then you get into the input ones, on turn, on move, on fire. And if I added more actions, they'd appear there as well. And because I've got this set to broadcast messages, the default is send messages. This will send those messages down to every object. So if I want any object in there to respond to input, all I need to do is to create a function that is called on turn, on move, or on fire, which later in this lesson you'll see me do. So I'm not going to get too far into it now, but that's how input is set up. So what other systems have I got here? So I've got a game manager object, again with nothing on it, apart from the player input manager. The player input manager component is the component that keeps track of player input components. So normally you'd use this to create functionality where a player could join by pressing a button. This is the component that would manage that. Its existence here is just to keep track of player components that exist. So for example, if I press play, you should see, yeah. So it's recognized one player container, screen number 0, which is this one. And that has been assigned the only device that's connected, the only compatible device that's connected right now, which is my keyboard. Now, if I connect a controller, so I've got an Xbox controller that I've just connected. If I duplicate this, it should recognize it's a second player and assign that controller to it, which it has. Fantastic. So that's what that component is for, the player input manager. That's why it's there. So let's talk a bit more about the player object. So the player has a rigid body 2D attached to it. So a rigid body component basically it allows a object to be moved using physics. So there are two types of physics objects essentially. There's a physics object that does not move, and there's a physics object that does move. If you add a collider to an object, and you can see that I've got a collider added on a separate object here. The reason it's on a separate object is just so I can turn it on and off. If you add a collider to an object, you give it a physical presence in the world. So it can either be knocked into, or it can be used to create a kind of trigger where it doesn't obstruct objects, but it can be used to trigger things. And that works in conjunction with the rigid body that allows it to move. Now, the gravity is set to 0. So this has no gravity right now. It has mass, but it ignores gravity. So Rigid Body 2D and Rigid Body 3D, I think, work in different ways with this. Rigid Body 3D, I think, has a use gravity checkbox, whereas Rigid Body 2D has a gravity scale. So if I put this up, then suddenly it's got real gravity. I could do -1, it'll come back up again. And the point of this is that I'm creating this top-down physics where the object can be moved around using physics but doesn't just fall down. And all of the objects work in this way. So the ship, the asteroids, not the projectile. I'm going to be using transform to move that. Again, that's something I'll get into in the video. But in terms of how this project is set up, I'm using physics to move the objects around, but I'm ignoring gravity. So they have no gravity scale, where if a gravity scale of 1 would mean that they have normal gravity, but they do have mass and they are moved using physics. So a bit about the collider. The collider is a polygon collider 2D, and the reason I use this is because you can create, let me move to the side, you can create shapes using polygon colliders. So I can actually edit these shapes like this. And that's basically how I created a triangle collider. And I did the same thing for the asteroids. They have Polygon Collider 2D, where they've just got these like simple shapes to approximate the edges of the asteroid. So going back to the player, there is also a display object. So this does two things. It renders the display of the ship, which again, this is a separate object so that I can turn it on and off. So if I want to flash the player, that's how easy it is to do. The separate fire display is going to be used in the lesson to create a visual effect for when the ship is moving. The reason you can't see it straight away is because even though it is visible, it has a transparent color. So its color is orange, but its alpha is 0. And this is what I'll be using in the lesson to turn this on and off. On the rest of this object, I've got an audio manager object. All it is an audio source ready to be used. Then I've got asteroid, explosion, and projectile pools. These are just empty game objects. They don't do anything. We're going to set them up during the lesson. And then I've got the canvas with the UI. Now, this uses the old UI. There is a newer UI toolkit that you may or may not use. This is a very simple UI, so I just set it up using legacy components. For example, these are just text fields, even the ship display. So the score text is just these zeros. And the ship display is just 3 upward arrows in this particular font, which is included in the project. So you can see the font down here. And then when these are updated, the script will just change the text of those fields. That's literally all it does. So the last thing I'm going to talk about is how the scene looks. So there are 2 elements to this. I've got a post-processing volume in the scene, which is just an object in this scene object here. And that is what is creating these effects. So I've got vignette, I've got bloom, I've got grain, and I've got chromatic aberration. And those are enabled by this volume, which if you turn off, they all go away. And on the main camera, a post-processing layer, which again, if you turn off, the effects go away. The last aspect to this is these stars. Now this is, I believe, just a particle effect. So it's just creating particles. So if I turn them off, they're gone. And that is pretty much it. Throughout the lesson, you'll be seeing how I'm going to use these objects to create the gameplay for this simple game. But if you want to get the scene looking exactly the same as I have done for the rest of the lesson, that's how you do it. Okay, so the first thing I'm going to do is I'm going to create a movement script for the player object. And I'm going to add this on the player object, not the container with the input component on. I'm going to add it onto the actual player object on the same object with the rigid body on, because what this is going to do is it's going to apply force to this rigid body, I want to apply a force to move it, and I want to apply a force to rotate it using the input messages that this is going to send. So you can see these. Sorry, I just need to move my microphone so I can see this. So you can see these messages, so you know what it's going to say. It's going to call on turn, on move, and on fire. And if you look in the input actions, that's these input actions: turn, move, fire. So you know that that player input component is going to call on turn, and it's going to pass this data, the axis data. So that's what we're going to use to create movement. So I'm just going to add a movement script. Then I'm going to open it up. Right, we just make this nice and big. Okay, so I'm going to get rid of all of this because I don't need it. So what do I need? I need a reference to the rigid body. So rigid body 2D, I'm just going to call that RB. And I need serialize field. Move speed equals, I'm just going to do it as 1. Oh, it needs to be a float. But I just want a way to change it if I decide to later. And then turn speed. And these are serializable because I want to be able to change these in the inspector. Now, when you're working with physics, I know in the previous lessons I talked about units per second. Physics works a little different in that it is usually done in, I think it might even be done in newtons, but it's done in a physical force unit. So when you apply force, you're applying units of force, which is a little less easy to judge how much it's going to move or turn an item. So you usually just need to start with something and then see if you like it or not, and then change it from there. Okay, so what else do I need to do? I'm going to store the axes for movement and turning locally. The reason I'm going to do this is because the functions that read the input data and the function that actually applies forces to the object are going to be different. The functions that read the input data are going to be called just after update, I believe the input system processes, and fixed update is called infrequently. It may be once a frame, twice a frame, no times a frame before any of those. So you have to kind of have this go-between in a variable, and that's why I'm going to create 2 variables to hold that data. It doesn't need to be particularly complicated. They can both be floats. So I'm going to have float move axis and float turn axis. And then I'm going to get in awake components rigid body 2D. I could serialize the field and just drag this myself, but it's only going to happen once and it's just a bit cleaner. It's not information I really need to have in the inspector, so to make it easier to look at, it's better if it's just not there. Right, now I'm going to write functions for the onMove and onTurn messages, and these take an input value type. So this is a data type that is specific to the input system and that carries the types of data that the input system might give to you. So I'm going to need to add the using Unity Engine input system namespace. And then void on move. Whoops. Input value. Just going to call it value. And I'm just going to copy and paste that for the on turn one. On turn. Okay. And the way this works is that you can set move axis equals value, so that's this value that the input system is providing, and there'll just be a function in that called get. What you need to do is you need to tell it what type of data you want, and I want to float. And then I'm going to multiply that by move speed to scale it. Because this is going to be used in a built-in physics function, at no point will we have to scale this by delta time. Usually you would. If you're going to move something by its transform, I'd be adding delta time onto this, or when I move the object. Because physics functions already do that for you, there's no reason to scale the force that you pass in by delta time. Okay, and then what I'm going to do with that, actually, let's do the turn axis. So turn axis equals value.get floats. And same thing times turn speed. Okay, so now in fixed updates, I'm going to apply these values to the rigid body using physics functions. So RB add force transform dot up, so that's local up, times move axis. And then RB dot add torque turn axis, and that's all you need to do for torque, is it just takes one value, which is the angle. That's it, that's all it takes. So add force adds physical forces to a rigid body. This comes in two flavors, an accelerating force, which is what I'm using here, or alternative, you can change the force mode to impulse, which is like a hit. You'd use that for jumping, for example, or an explosion. That's not what we're doing here, so I'm going to take that out. And then lastly, what I want to do before moving on to something else is, if this script gets disabled, which it will when the player dies, I want to run this game by turning objects off and on again. I don't want to be destroying objects and reinstantiating them. So whenever an object's turned off, we're going to be considering that it is destroyed and needs to be reset. So if a system gets turned off, it needs to stop doing what it was doing. And in this case, that's set the move axis to 0, set the turn axis to 0, change the velocity of the rigid body to 0. The velocity is, this is not a value you'd normally change because you get weird behavior with it. The velocity is its current momentum, and it's a vector 2 value, so you can use vector 2 0 to set it to nothing. And then that's it, and then I'm going to save that, and then I'm going to test it. We've got a controller connected. This should just work. It's moving slowly and turning fast. We're going to change those to something a bit more manageable. I'm going to try 5 and 3. See if that's a bit better. There we go. Okay, so the next thing I want to do is, I've got on the player object a little fire display, which is currently transparent. There it is. And I want this to become visible when the player is moving. So I'm going to go back into the movement script and just connect that up. So this is pretty easy to do. I just need a sprite renderer reference. I'm just got to call it fire sprite, because if you look at what it is, it's a sprite renderer. So that's all I want really. And I'm going to get that in awake. It's in a child object, so I'm going to use get component in children. Sprite renderer. And then when the player is moving, I'm going to change the fire sprite color to a new color, because there's no way to change just the alpha. And it's going to be existing color R, existing color G, existing color B, and then the alpha. So I can't use the move axis because this has been multiplied now by the move speed. I'm just going to change that to what I changed it in the inspector. This has been multiplied now by 5, so it's not going to work properly. So I just need to get the movement, the raw sort of movement value again, and then end that statement. And what I want as well is if this script is disabled, I just want to set that to completely transparent. I'm going to save that and go back in. It's not worked properly. Why hasn't it worked properly? Because it's looked for the first sprite renderer on the object, which is the ship. So what I'm going to do this instead is I'm not going to do that. I'm just going to serialize the field, then save it and connect it myself. There's good reason to use get components to set up your references, because then you don't have to look at something that you don't need to do anything with, which just makes everything a bit neater and a bit easier to process mentally. However, when the object is going to be a prefab and you just set all these connections up, if these aren't going to ever change, there's nothing wrong with doing it this way. It's pretty efficient to do it this way. Now, if it does change, let's see if it works first. It does. If I do it halfway, yep, it does it halfway. If it does change, as in if I decide I don't want this anymore, then if I delete the fire sprite, suddenly this stops working and I get an error. Now, you could say, well, that's true of the rigid body as well, and it is. But if we look at what this script does, this is a movement script. And the only reason I'm doing this in this script is because it's convenient. However, it is not what this script does. Really, if I was keeping everything neat and separate, I might move this into a different script and use something like an event to notify other systems that the ship is moving, or that the movement script is receiving input, and then these would be completely separated. And this is actually something I did I did a video on object connections where I connected these two systems using events, and the idea is that you could take one off without breaking the other one. We're not at that stage yet. That's stuff we'll cover in the advanced module. So that's one of the reasons I've done it this way, is because I wanted to do all of the things I'd shown you so far without doing too many things I hadn't shown you. But just know that this is something that I would usually either put in a different script, or, assuming that you might change it later, just null check it first. So, for example, we can if fire sprite, and then now if we change our mind about it, okay, yeah, that code is still there, but it doesn't break. So if I hit play again, oh, I hate that effect now, I'm deleting it. The game doesn't break, it still works. So just something to keep in mind. Okay, the next thing I want to do is the physics objects in the game, so the player and the asteroids, I want to move them to the other side of the screen if they exit the bounds of the viewport. So, for example, if I take one of these asteroids, so say if this moves out the top, I want it to just come out the other side. And I want that to happen for all of the physics objects. So I'm going to do that with a script. I'm just going to put it on the player there. I'm going to put it on the player first, and then I'll add it onto the asteroids. I'm just going to call it infinite bounds and then open that up. Okay, so this is going to be a physics script because we're moving these objects with the physics system, so it makes sense to check where they are and adjust their position using the physics system as well. That means that we need to get a rigid body 2D component. Always be careful between rigid body and rigid body 2D. It's very easy to get them to use the wrong one, and it will drive you insane because it doesn't always cause an error. It just won't work. So then in awake, I'm going to do RB equals get component rigid body 2D. So why am I not null checking this? This script only works with a rigid body. If it doesn't have a rigid body, it can't do anything. It shouldn't be on the object it's on. So if it doesn't have a rigid body to work with, I want it to fail. I want it to fail and give me an error. So that's why I'm not bothering to null check this. I'm also using get component and not creating a serialized field and dragging it to it because I don't really need to do that. The objects are going to be created at the start of the game, so very rarely will this be running in the game unless the pool runs out of objects, which it's unlikely to do. So I'm not worried about using this, and it keeps it out of the inspector. So, how am I going to do this? In fixed update, not update, because remember, we're using the physics system. So fixed update. I'm going to create 2 points, a top right corner and a left corner, that are representative of positions in the world in relation to the edges of the viewport. And then if the object is outside of those in any direction, plus a buffer, just to make sure that it definitely is outside, I'm going to move it to the other side. So I'm going to create those corners, and then I'm going to check the position up, right, down, and left against those 2 corners to see if it needs to be moved. So I'm going to start by doing the buffer, which is, I'm just going to use the size of the object, specifically the width. Transform.localScale .x plus a little bit. I just want to make sure it definitely is off the edge before moving it to the other side. The reason I'm using this and not a static value, or a fixed value I should say, is because I want to be able to have objects that are different sizes, and then it still go all the way off the screen before it moves. Right, next I'm going to do my 2 corners. So the way I'm going to do this is with a camera function called viewport to world point. So what this does is you pass in a representative position on the viewport, and you can do this with pixels as well, but I'm choosing to do it in a 0 to 1 scale, where 0 and 0 is the bottom left and 1 and 1 is the top right, and 0.5 is the middle, to create those 2 points in the real world. And then if the viewport changes, those points are still correct. So here's what that looks like. I'm going to do vector3 top right corner equals camera dot main dot viewport to world point. And something I might do actually, just to avoid using camera.main, is I might just get a reference to the camera. So camera cam equals, and then just camera.main. For 2 reasons. 1, so I don't have to type camera.main over and over again. And 2, I believe it might be slightly more efficient to do it this way. I'm not 100% sure that it is, but it's not going to hurt. And then new vector 3, 1, 1, and then I don't need to pass anything into the Z because it's irrelevant. So what this is doing is it's specifying a point in the viewport at 1, 1, so top right corner, and then changing it to a world point. So it's here. Now I'm going to do the same thing with the bottom left corner. I'm just going to copy that. Bottom left corner. Except it's going to be 0, 0. Okay, so those are my 2 points established. So now I need to check if an object is outside of them. So the way I'm going to do this is I'm going to create a new position and just edit it as I go. And then if I have to edit any of the dimensions, so the x or the y, I will change a Boolean value to true so that I know by the end of all my checks, I do actually need to move the object. So I'm going to start with Boolean move object equals false. I'm assuming I don't have to move it. And then vector 3 new position equals rb.position. So RB position is the rigid body position, not transform position, the rigid body position. And this is important. The reason it's important is because it's more efficient to move a 2D physics object using the physics engine than it is to move it using its transform component and then let the physics system work out where it is. At scale, it causes an issue. And because this script is going to be on a lot of different objects, you just need to be mindful about doing things the right way in this script. So it's not like you've used a cheeky get component once, or you've used a find operation once, and it's going to happen at the start of the game once and never be repeated again. This is going to happen every fixed update on every physics object. So we just need to be mindful about what we're doing. And one of those is just using the rigid body position to move this physics object, not using transform position and then just letting the physics system do the extra work to work out why that collider has moved. So I'm going to do my 4 checks now. So all I'm going to do is check to see if the new position, because this is now the object's position, is greater in any dimension than the top right corners or bottom left corners x and y values. And if it is, change those to the other side, plus or minus a buffer. So here's what that looks like. So if new position.x is greater than top right corner .x plus size buffer, then it is out of bounds. Specifically, this would be to the right, in which case new position.x equals bottom left corner, so the opposite side, .x. So set it to this minus the size buffer. And then change move object to true. So we've had to change one of the values, so we are going to have to move the object at the end of this, so we're going to change it to true. And then all you need to do is do this another 3 times. So copy and paste that. So I should get the pattern of this right. So new position.x is less than bottom left corner minus size buffer, then set it to top right corner plus size buffer. Then we move on to the y's. New position.y is greater than top right corner plus size buffer. The new position.y equals bottom left corner minus size buffer. And then we do the same thing, but we swap it around. So less than bottom left corner y minus, because it's a less. We set it to top right y plus. And then at the end of all this, if move object is true, RB position equals new position. Right, now it's on the player at the moment, so we're just going to test that and see if it works. See if I've mixed up any of my axes. So it works up and down, and it works left and right. Good, okay. And then on the asteroids, I'm just going to add infinite bounds and save. The next thing I'm going to do with this is just set up something I'm going to be using later, which is the audio manager. So I've got an audio manager object here with an audio source on it, and I'm going to add an audio manager script. And then open that up. There we go. Right, so this is the first globally accessible script that I'm making. And think about what it needs to do. So it needs to be accessible from everywhere. It needs to access something that exists in the scene, so the audio source that it's going to play audio through. And there will probably only ever be one of these, which altogether, that makes it a good fit for a singleton, which is what we're going to do. So I'm going to create a public static reference, audio manager reference called instance. So all this is a reference to the type of audio manager called instance. And the only difference is that it's static. So it's shared between all instances of this. So the audio manager class is not static. There can be many of this, but the instance reference is static. It can only point to one memory allocation. So all of the instances of this will point to the same place, which is how singletons work. But for that to work, you need to make sure that there is only one of these in the scene. And since there can be more than one, you need to make sure that there isn't. So to do that in awake, we're going to do if instance is not null, so if it's not empty, and if instance is not this, so if it's set to something and it's not set to this instance of the class, then it shouldn't exist. It means that this is a duplicate, in which case we need to destroy this, which will just remove the component. And then after that, set the instance to this and finish setting up the object by, we need to create an audio source reference. Audio source, and then set that audio source equals get components audio source. Okay, so if there is an instance that's set, and if it's not this, then destroy it so that the script never gets to here. Actually, I'm gonna put return in there because I can't remember if destroy exits out of a function when it's called. So my thinking is that this, even though it's being destroyed, it will still process the rest of this. I can't remember if it does. Let's test it. We'll just test it. So this is one of those situations where if you don't know how something works exactly, then you can just test it. And I promise you, most people don't do this. Most people they'll check the manual, or they will check online, or they'll check a forum. A lot of the time, it's quite easy to just check if something works in the way you do or do not expect it to by testing it yourself. So, for example, in this case, we want to know, does destroy stop this function from going any further? Meaning that this is never executed. And all we need to do to test that is to break it, to create the situation that we don't want. So we're going to have a way to measure it. So debug.log I'm still here. And then I'm going to create two, which is what we're not supposed to do. So what should happen is one of these will be destroyed. What shouldn't happen is we shouldn't get 2 log messages saying I'm still here. We should only get 1 if destroy returns out the function. So let's see what happens. So 1 gets destroyed, but we have 2 log messages, which means that this still gets executed even though the object is destroyed, which I couldn't remember if it did or not, and it does. So we need to do this. Actually, I'll just keep the debug log in because I want to test this. So I'm just going to return out. And then what should happen is one of these is destroyed, but we get 1 message, which we do. And that took, what, 2 minutes to check, and now we know. So now I've created the singleton instance, I'm just going to create a public function. So I'm going to create a public void play sound effect function. And all I'm going to do with this is I'm going to recreate the play one shot function that an audio source has on it, and just pass the same information into that. So volume, scale, and clip. And then I'm going to call audio source.play one shot, which what this does is it plays a sound on an audio source, but if you play 2 in a row, it doesn't cut one off. It overlaps them. It does add up to your voice count, but this is useful when you want to play sort of single sound effects, as in not loops, using just one audio source. So then just pass in clip and volume scale. So why am I doing it with a function? Why am I not just making this public and doing it through the audio source? Glad you asked. Well, the reason I want to do it in a function is because I want to be able to easily change in one place how playing a sound effect works. So the acid test for is something a good way to do something is how easy is it to change later if you want to. If I had other scripts using the audio source directly, doing this directly, then there's no opportunity to put anything else in there in a single location. I have to go to every script and change how it works. Whereas if I want to put something else in here that changes how audio sources are played, I can do it just here in the one place that it's called and keep this private. So that's why I just prefer, even though it looks from the outset, it just looks quite wasteful that I'm using a function to do the exact same thing as the function on here. From a management point of view, it just makes it easier to change later on, which I like to think of as the test of if a project is easy to work with, is it easy to change? So the next thing I'm going to do is I want to create an explosion effect that scales down a circle sprite, that's this sprite here. It scales it down in size and plays a sound effect, which is why I added the audio manager in the previous step. So this is our explosion, and I'm going to reduce it down in size over an amount of time whenever it's turned on. So you turn it on and it disappears, plays a sound, and then turns itself off again when it's done. The idea is I want to be able to just move this to a position, turn it on, it does its thing, and turns itself off again. So let's do that. Now, the way that I'm going to do this is with lerp and a coroutine, because I want to do something that's controllable by time. I want to change a value over an amount of time, which is usually what lerp is good for. At least when you want to control the amount of time it takes. And it has a start and an end. So instead of trying to check the state of it with if conditions, it's just easier to put it in a coroutine, which has a start and an end. So because we're using coroutines, we've got system collections already. That's fine. And I'm going to take all of this out because I don't need it. And the first thing I'm going to do is I'm going to create some controls for this. So float duration equals 0.5 f. And then I want to be able to control the easing of this in the inspector. I don't want to have it linear. and I don't want to have to do stuff using maths in the function. I want to just tweak how it looks. And the best way to do that is with an animation curve. And you'd be surprised how often you can use these for all sorts of like 0 to 1 things where you want to change it from something that's linear to an eased function or a smooth step or something like that. You can just use an animation curve. It's not always the best way to do it, but it is especially good when you want to tweak how it is while it's running. And if you want to create something that's not easily recreated using say like normal mathematical functions. So the next one I'm going to create is audio clip just for the explosion sound effect. So I need to create the coroutine. It's going to shrink the scale of this object. Okay, so what needs to happen? Well, first, I probably need to trigger the sound effect. So I'm going to go Audio Manager. Remember, this is a singleton. We just set this up. So Audio Manager dot play SFX. Now, why isn't that working? Because I haven't done instance. Now, this is a really easy thing to do with singletons, is to forget that you need to use that instance reference in between. So when you usually use statics, you can just type Audio Manager and then you just put whatever it is you're trying to access next, and it works. Because it's a singleton, the thing that's static is the reference to it. So you have to remember to put instance, and then you're using the instance of it. So that's where play sound effects turns up. I'm going to pass in the explosion sound effects and volume scale of 1. Okay, so that's the sound effect out of the way. The next thing we're going to do is we're going to start changing the size of this. So float start scale. So we need a start size. And the way I'm going to do this is I'm going to change the start scale to the current size, at least the width of the object. Then I'm going to create a float that's just called scale. That will be the scale that's changed over time. And then I'm going to create a float that is the timer. That will just keep track of the lerp as we move through it. So, got all the bits ready. So while timer is less than duration, float t equals timer divided by duration. So this is usually what you'd pass into the t value for the lerp. The reason I'm doing it here is because I'm going to modify this with the animation curve when I actually pass it in. And then scale equals math f.lerp. We need to pass in 3 values. So the start, the end, and t, which is basically the weight in between those two, the mix value, if you like. So the start is the start scale. The end is 0 because we're trying to shrink this to nothing. And then the t value would be time divided by duration, but it is t. Actually, no, it's not t. It is curve dot evaluate, and then you pass in t. And what this does is, let me just get rid of this error so I can show you. Yield break, just to end that. So what this does is when you've got your animation curve, so I'm just going to change this to a smooth step, is basically t is evaluating where it would normally be this. It's adjusting it to the eased position on the curve based on the time value. So this is t along the bottom, and then this is the corresponding value. Normally it would be linear from start to finish, but in this case you're using the curve to adjust it, and that's just the function you use to do that. So next I'm going to actually change the size of the object now to vector 3 1 times scale. So even if this starts at a lower scale than say 111, say if the start scale is 0.5, 0.5, then the scale is going to be that value to start off with. So 111 is going to be multiplied by that scale, which means it'll start from, say, whatever it is. That's why we like to use 1 as a sort of like a scaling value. And then timer plus equals time dot delta time to advance the timer. And then, really importantly, because we're in a coroutine, yield return null, which at this point, it suspends the operation until the next frame while this is still true. And when this is no longer true, lock it, transform dot local scale equals, we can just do vector 3 dot 0, so it's nothing, and turn the object off. So game object dot set active equals false. I didn't start the coroutine, so I need to, I want this to happen every time the object is turned on, so I'm going to put this in on enable start coroutine shrink scale. Now it should work. Why didn't it work? Because we've got a null reference error. Okay. Is this the audio source? So if I do this, this should fix it. Yeah, okay. That's actually really useful. So in my preparation for this, I had to manually recreate this error to explain it to you, and then fix it. The reason this is happening is because this is being started in on enable. And if you remember back to the lesson on timing, awake and on enable are called one after the other on a per script basis. So whereas every other event function is called on every script, and then you move on to the next event function on every script. So you can always count on, say, update being before late update, for example. Awake and on enable do not work in that way. So what is happening here is awake and on enable are being called on this script before they're being called on this script, which isn't a huge problem because it's unlikely that you're going to have a situation where you've got an explosion playing at the start of the scene. But you might, or you might have a different sound playing at the start of the scene. And because this is a special case where you've got something that absolutely needs to be there for other objects, and there's no real way to change this because the way I'm doing this, I want to be able to call things in on enable because I want it to happen every time the object's turned on, then the only real way to do this is by altering the script execution order, which is exactly what it's for, is this kind of problem. So the script execution order changes a script's default time. So if I go into project settings, I can add a script to this, so I can add the audio manager. So right now it'll happen after default time, so later than everything else. And when I prepared for this, I had to demonstrate this by basically doing this to force this error. And this just highlights that the instance order between projects is completely different. So on a project installation basis, because I copied the project to create this version of it, the order that instances have their script messages called, so the order in which, say, awake and on enable is called on these objects, is completely different. And it's the same thing when you build the game, which is why sometimes you have completely unknown errors that didn't happen in the editor. And as soon as you build it, you suddenly have null reference errors that weren't there before because there's a timing conflict. So the way to fix this is just, you can either change this to a value lower than 0, or you can just drag it. So these values don't mean anything, they're just relative. They're relative values. So it does not matter what this value is. The only reason they exist is to weight these so before other things. But all it needs to do is happen before default time, meaning that of all the scripts, Audio Manager will be called first. So it will have its awake and are unable called first, and then all of the other scripts will have their awake and are unable called, and so on. So what will happen now is I won't get that error. So just apply that. And it has to recompile, and now I won't get an error. Oh, I did get a warning because there's a null audio clip because I haven't put the clip on, but I didn't get an error. Here we go. There we go. And then every time I turn it back on again, it does it again. The reason you can't see it is because it's setting itself to its original size. The reason I'm doing that is because when I spawn this from an object, I'm going to set it to the size of that object. So that's why you can't see it at the moment, and why I'm not fixing that particular problem at the moment. But what I will do is I will just change that so I can re-trigger it while I change the animation curve to get it looking how I want. So I'm going to change the start scale to, I think it was 0.3. That's what it normally is, yeah, 0.3. So this should now work every time. Yeah. Okay, so now let's find a curve that I like the look of. So let's try that. Okay, so I like that a bit better, but I want it to linger at the end. There we go. Yeah, that'll work. Now I just have to recreate it. Can I copy this? No. Ooh, I know what I can do. So here's a trick. So I'm in play mode. When I exit play mode, this is going to reset. But you can copy the component, and then you can paste its values. And now it's as it was. Okay. So I'm going to go back and I'm just going to change this back to what it was before, which is the local scale. So what I'm going to do is, when I am creating this, is I'm going to set it to the size of the thing I'm exploding. So what I could do with this now is create a prefab with it. So this is the first, is actually the first prefab. So let's create a prefabs folder. Prefab. And I'm going to turn the object off because I want it to be off. I want to be able to turn it on when it's ready. So I'm just going to drag that to there. Now it's a prefab, and now I can delete it. There we go. Okay, so I've got an object that I want to repeatedly use now, my explosion prefab. I'm going to create an object pool script to use with objects like this, ones that I want to repeatedly turn on and off, so that other scripts can say, I want an explosion, gimme. So that's what I'm going to do now. So on my game manager, I've already got an explosion pool game object set up. It's just an empty object. I've got one for asteroids and projectiles as well, but I'm just going to start with this. And I'm going to add an object pool script. Take all this out because I don't need it. Right, so what do I need to create an object pool with? Well, I need to know the object I'm going to pool, and then I need to create a bunch of them, so I need to know how many I'm going to do of that, and then I need to keep track of them, so I'm going to probably have to have a collection of references to those objects so that I know what objects exist and which ones I can give to other systems. So let's start working through that. So I'm going to do serialize field, game object, pool object, and then I'm going to have a serialized int, which is number to create, and I'm just going to set that to 20 to start. I'm going to create a list of the type game object called created objects, and I'm going to initialize that list to a new list. And then I'm going to have a private integer, which is the index. So this is going to be the current point in the list, because assuming that I'm just going to enable one object after the other, it makes sense to just move through and then search the rest of the list if there's any problems with that. So I'm going to have an index number to do that with. Right, so in the awake function, what I need to do is create 20 objects. So for int I equals 0, where I is less than number to create, I++, and then create the object. So I need a function to create the object because I'm probably going to do that more than once. So I don't want to type it out manually here. I want to put it in its own function. So it's going to be a function that returns a game object type called create object. Game object created object equals instantiate pool object, and then you have an option to decide what the parent object for this new object will be, and I'm just going to make that this transform, so it will be created as a child object of this pool object. So this works because instantiate returns a reference to the object it creates, so you can actually do stuff with it afterwards, which is what's being set here. And then created objects, the list, I want to add this object and then return it. Okay, so now I can just put this in here. So in this case, I don't need to use the reference that's returned, but I may want to later on. So all I'm doing is calling create object and not doing anything with the data that it returns back. So now I want to have a public function for when another system requests an object. So I need a get object function. So public return to type of game object, because you're going to want to get the object. Get object. And then what I need to do here is I need to work through the list and find the first one that is disabled, and then give that back. So the way I'm going to do that is for int I equals 0, where I is less than created objects dot count I++. This is a little bit complicated because it's a loop inside of a loop, essentially. I'm using two numbers for this. The index, which will be my running position in the list, and this integer I, which is literally just going to be a counter to do something so many times. So when this reaches the created objects count, it's not that I'm starting at the start of the list and then moving to the bottom. It's that I'm doing something for the total number of items that are in the list, starting from a midway point. So it may be that I created the third object last time. So this time I start at the fourth object and I want to cycle through all the way around until I get back to the same point. So that's why I'm using createdObjects.count, even though I'm actually going to be using the index value and incrementing that to return one of the values. So that's what I'm going to do next. So if createdObjects.index, so this will be 0. Dot active in hierarchy, meaning that it's enabled and is active. So that means that the object is enabled and its parent is enabled. So it's not just enabled, it's enabled and available. In this case, we want it to be disabled, because if it's disabled, it's available to use. Then I can return created objects index. So if the object I try and get is not disabled, I'm going to increment the index, and then it will do it again. And then if the index is greater to or equal than createdObjects.count, then I'm going to set it to 0 to start it from the start again. And then if the function gets to here, then it means that I've gone through every object in the array, the list, sorry, and none of them are disabled and available for me to use. So I need to create a new object. So I'm just going to return the result of this create object function. And that's it, that's all I need to do. Okay, so I created the object pool script and now I need to set it up. So I need to set the pool object to the explosion, like that. And I'm going to change the number to create on this because the explosions don't last very long. So it's unlikely that I'm going to need 20. So I'm just going to change it to, I don't know, 10. It would still be overkill, but it will be fine. Now I need a way for other systems to access this pool and create an explosion when they want one. So it's time to make the game manager script. So I've got a game manager object with nothing on it, and I'm going to add a game manager script. Now you might have noticed that the game manager script in the project gets this funky little gear icon. That does not mean anything other than this is called game manager. It's just something that it gives it a special icon because it's called game manager, but you don't need to worry about it. It doesn't change it. You don't have to avoid calling your script game manager. It's a quirk of Unity that's been in there for ages. So let's start writing this. So the game manager, in the same way as the audio manager, it needs to be accessible to everything and it needs to manipulate data that exists inside of the scene. And there probably won't be more than one. So a singleton is fine for this. So I'm just going to do that. So same as before, I'm going to do public static instance, public static game manager instance, and then in awake, I'm going to create the singleton. So if instance isn't null and instance isn't this, destroy it. And we know now to return while you're at it. If not, instance equals this. Okay, so that's the singleton. Now we can create a reference to the explosion pool. So I'm just going to do public object pool explosion pool. It needs to be public, not serialized, because other scripts will access this. But then what I can do is back in the inspector, go to the game manager, and I can just drag the explosion pool object to the reference because I know it's on there. And that's it. That's all we need to do for that. Okay, so I'm going to carry on with the asteroids. Now I need to create a script that will allow an object to be damaged and destroyed. And when I say destroyed, I mean turned off. So I'm going to pick an asteroid. Actually, I'm going to put on all the asteroids. Damage. Double. And again, I don't need this. Right, so it's something I like to do with scripts is, this is kind of like the script composition method where you, instead of having scripts as inheriting classes of other classes, you kind of have scripts as abilities. So if you want to make something damageable, you create a script that is damageable and then you put it on there, or selectable, or movable, lots of things that end in able. You can also do this with interfaces, which we're going to learn about in the next module. But generally, I just like this idea of limiting a script to the ability it enables, and then you can just throw it on any object you want. So that's what I'm going to do with this script. So for something to be damageable, it needs to have health. And every time the object is enabled, I want to reset that health. So void on enable HP equals 100. And then I need a public damage function. So a function that allows other things to damage this. Now I'm going to have this return a Boolean value. And the reason I want to do that is because I want the thing that's damaging the object to be able to tell if it's been destroyed or not. And the reason for that is, for example, say if you want to score points when you destroy an object, well, you need to know that you've destroyed it, for example. Or if you want to remove a life from the player because it's been destroyed, well, you need to know that it actually has been destroyed. So this is going to return a Boolean type. It's called damage, and it takes a damage amount. Damage. So one thing to know about functions on scripts, on components specifically, is that if you have a reference to a component and you can call a public function on that component, it does not matter if it is disabled. You can still call that function. So the only thing that turning a script off does is it prevents the event messages from being called. Things like on enable. It does not stop functions from being called. So I want this damageable script to work in a way that if I want something to not be damageable, I want to be able to turn it off. So I'm going to do if is active and enabled, and then put everything in this if condition. Or I could just actually, nicer way to do it is if it isn't active and enabled, just return false. You definitely didn't destroy it, and you didn't damage it either. So now we get into the actual function. So HP minus damage, and then if HP is now less than 0, well, the object has been destroyed, in which case we're going to create an explosion. Game object explosion equals game manager see, remember I was talking about the instance thing earlier? I've tried to type explosion. I do this all the time. Instance dot explosion pool get object. Right. Now explosion transform position equals this position, and explosion transform local scale equals my scale. There we go. And then turn the explosion on. With set active true. Turn this object, which is now destroyed, set active false. And then return true, because the object was destroyed. Now, still an error because I haven't returned all code paths, so there is a possibility that you can get to here without returning that, so we need a catch-all, which is return false. So if it wasn't destroyed, it will return false. If it was destroyed, it will return true. If it's not enabled, it will return false. Okay, so the asteroids are nearly done now. Before I make them into prefabs and take them out of the scene, I want to give them some random initial movement and rotation and have them set their own random position. So let me just add asteroid script and open that up and take this out. So what do I need the script to do? Well, I need it to give the asteroid a random size. I need to give it a points value related to that size. And then I need to give it some random movement, rotation, and set its random position. I'm going to start with a reference to a rigid body. And then I'm just going to, in awake, set that. So RB equals get component, rigid body 2D. Okay, and then I want a points value that's publicly accessible, but I don't want it to be visible in the inspector. The reason I don't want it visible in the inspector is because I don't want to have to change this myself. So I don't want to see it later and think, oh, that's a value I need to set. It's not. It needs to be publicly accessible, but it does not need to be visible. So I'm going to hide it with hide in inspector. Points value. Right. So on enable, I'm going to set this object up. So first I'm going to give it a random scale. So transform local scale equals transform, local scale times random range between 0.5 and 1.5. So this will work the first time, but there's a possibility that as this object is turned off and then on again, off and then on again, it could keep getting bigger, or it could keep getting smaller. So what I need to do is anything I initialize in on enable, I need to undo essentially in on disable. So what I'm going to do is I'm going to change the, I'm going to do this exact same thing, but I'm going to use a default value. So I need to create float default scale and then set that in awake default scale equals local scale, just take the width, whatever it is now, and then multiply it. I'm going to go with vector3 1 times the default scale. So the reason I've done that is it's not actually 1, 1, 1, these asteroids, they're 0.3. So it will take that into account. Okay, so that's that. What do I need to do next? I need to set the points value, and I want to have different points values depending on how big the object is. So bigger objects score more points. So to do that, I'm going to set the points value as equal to 100 points, and then scale the 100 points by transform dot local scale dot x. Except there's a problem. So the problem with this is that local scale dot x is a float, and this is an integer. So what I need to force this to be an integer, which I could do. I could cast it by doing that. So this now compiles, but it's not going to work. Well, at least not in the way I want it to. So what I want is say the scale is 0.5. I want it to take 100 and times it by 0.5 and give me 50 back. That's not what's going to happen here. What's going to happen is it's going to cast it to an int, and it's at 0.5, it's either going to be 0 or 1. I'm not sure which way it'll round it. In which case I'll get 100 back or 0, which is not what I want. So what I need to do is put that together like that, and then round it to an integer by using mathf.round to int. And now it works. So now say if that's like 0.75, I'll get 75 points back, which is what I want. Okay, what's next? So now I want to set the random position. So I'm going to do this using transform position. The reason I'm using transform position for this and not RB position like I did with the infinite bound script is because I want to move this before it's visible. So as soon as this happens, I want to move it. Whereas if you change the rigid body position in something like on enable, that is not going to take effect until fixed update is actually called, in which case there's a chance that this would be visible briefly in the scene and then it would move when fixed update is called. So because I actually want to move it out of the way, I need to use transform position to do that. So now I need a random value. Now there's a pretty easy way to do this. There is no function for a random vector3, but there is essentially a function for a random direction, which is inside unit circle and inside unit sphere. So inside sphere does it returns a vector3. So it just points in a random direction at a random length between 0 and 1. And inside unit circle does the same thing but with a vector2. So this basically points in a random direction with a length of between 0 and 1, which is what I want. And then I can normalize that so that it's not between 0 and 1, it's 1. And then I can multiply that by some large number, say 50. And what that will do is it will definitely put it outside of the bounds of the viewport in a random direction. And it doesn't matter how far out I put it. As soon as fixed update is called, the infinite bound script is going to kick in and it's going to move it to an appropriate position because it will be outside of those bounds. So it doesn't matter that it's 50 units. It just needs to be big enough so that I don't see it. And then I'm going to give the rigid body some force and some rotation. So I'm going to do RB add force, random inside unit circle again, and then force mode impulse this time. I don't want to add this force over amount of time, I just want to hit it once. So I'm going to use impulse, and then RB add torque between -10 and 10. What's happened there? No, because I didn't do random range. Random.range. -10 and 10. There we go. Save that. I'm going to go back and see if this works. Yeah, there we go. So they've moved outside of the viewport and they are moving and ever so slightly rotating. Perfect. That's what I wanted. Just check that the bound script is working. It is. There it is. And this one. Good. That's the behavior I want. Okay. So these asteroids are basically ready now. So I can turn them into prefabs. They are each a little different, so I'm going to make one prefab for each. So I'm just going to go to my prefabs folder. Asteroid 1, Asteroid 2, Asteroid 3. And then I can remove them. Now I'm going to create asteroid object pools. So one, whoops. Paste component is new, paste component is new. And then I'm going to have each of these prefabs on each of these pools. I'm going to just randomly choose which pool I spawn an object from when I create the asteroids. Okay, so now that I've got the 3 object pools for the asteroids, I need to randomly choose from one of them when I want an asteroid. So I'm going to go back into the game manager to do that. So back in the game manager, I need a reference to the pools. But when I need a reference, I need an array. So I'm going to be setting this up in the inspector. So I'm going to serialize it. Object pool, square brackets to mark it as an array. Asteroid pools. And then I'm going to create a function to get an asteroid from them. So void spawn. What's happened there? Asteroid. So I want int I equals random dot range between 0 and the length of the asteroid pools. So this works because when you get a random integer, it is max exclusive. So it will not include the highest value you put in. So if this was random range 0 and 10, you'd get a random number between 0 and 9. You could get 9, but you won't get 10. In this case, the length of the asteroid pools is going to be 3, and the highest index I want is actually 2. So this works. So now I'm going to get the object from the pool. So game object new asteroid equals asteroid pools, pass in I, so that's the random one we're using. Get an object from that, please. And then turn it on, and that's it. New asteroid, set active is true. And that's it. That's all I need to do to create an asteroid. And then it will set itself up as soon as it's turned on. What I need to do now is actually spawn those asteroids at intervals while the game is running. So this is going to be part of the main game loop where I'll set up the players at the start and then continuously create asteroids in the middle and then end the game when the players are out of lives. And because there's that start, middle, and end, a coroutine is going to be a good way to do that. Put this in here. So IEnumerator. And I want this to be called straight away. So I can just use start for this. So normally you have void start, but you can call start as a coroutine by just giving it an IEnumerator return type. So instead of, say, doing void start and then starting the coroutine, I can just do this. Now, what do I need to do in this coroutine? Well, I need to do three things. I need to set up the players. I need to run the game. And then I need to end the game. I'm going to do this bit later. I'm going to do this bit later. I'm going to do this bit now. So I need a condition where the game is not over. So I need to create a Boolean game over. And then while the game is not over, run the game. So to do that, I'm going to spawn an asteroid. And then I'm going to wait. Yield, return, new, wait for seconds. Random range between 1 and 5. And that's it. That's all I need to do. That's what's going to happen when the game manager is managing the game. It's just going to throw asteroids in. So let's go back and see if that works. Oop, something went wrong. So what happened? So I haven't set up the reference, but there was another issue, and that is that my asteroids are still enabled. So I need to turn all of them off because I want them to be off by default when they're created, and then I want to turn them on when I need them. And then I need to go into the game manager and I need to create a reference to these pools. But I have a problem because I can't just drag asteroid pool to this because I only get one. I need all three. So how am I going to do that? This is a bit of a trick when you need to drag stuff between inspectors, basically. You can just make a second inspector. So I'm going to lock this inspector, meaning that it doesn't change. Then I'm going to add an inspector. Here it is. And then I'm going to select the asteroid pool object. So I've got the game manager locked here, and then I can just do this. Then I'm going to close this tab. I'm going to unlock the inspector before I forget. Save the scene and try that again. No errors this time. And we have asteroids enabling themselves. There we go. So next I'm going to create this projectile that the ship is going to fire. What I want it to do is I want it to move in update. I don't want to use physics for this because I'm moving it quickly and I don't want to have to interpolate it. I'm going to move it in update and check if it's over a collider. And then if it is, I'm going to damage that object and turn off the projectile. So I'm going to select my projectile and add a projectile script. So there's a couple of things I need to put in here that I will end up using later. So the point at which the projectile destroys an object, as in it destroys an asteroid, you're going to need to know which player did that. So this is the first time I'm going to have to identify who this projectile belongs to, because otherwise who gets the points? So to do that, I'm just going to put in a player number, a public player number value. And I'm going to use that to identify this. Actually, it doesn't need to be public. I'm going to use a serialized field for it. I don't think it needs to be public. I'm going to use it to identify which player fired this projectile, and so who gets the points. Right, I'm going to put some projectile settings in now. So, serialized field float damage equals 30. Serialized float speed equals 30 units per second. And serialized field float duration equals 5 seconds. So that's how long this is going to be alive for. Then I want to create some references to audio clips for this. So audio clip, the fire clip, and the hit clip. You don't have to put these here, but say if I wanted to make a different type of projectile, I might want to change how it sounds on the projectile, as opposed to having one weapon sound and then having to go into the script that fires it and change it there. It's just a bit easier to do it here. Then I'm going to create a timer. So this will just keep track of how long it's been alive. And then in on enable, what I'm going to do is audio manager.instance .play sound effect fire clip 1. And we know this will work because we changed the script execution order of the audio manager. Otherwise, this could cause a problem because this on enable could be called before the audio manager's awake, but we know it won't be. Right, so what does the projectile need to do in update? Well, it needs to move. It needs to check if it hits something. I need to advance the timer, and then I need to disable the projectile. So let's move it first. So transform dot position plus equals transform up times speed times time dot delta time. Now I need to check if it hits something. So the way I'm going to do this is with a physics function called overlap box that basically just draws a box in the scene and see if that is touching any colliders. And it does it without having a collider on this object itself, which is good because it means I can move it and update and then just query the physics system whenever I want to. I'm going to use the non-allocating version of this function, and the reason I'm going to do that is because it will get more than one collider potentially, and it needs to put those results in an array. And the regular version of this function creates a new array for that, which creates garbage, which can cause performance problems, which we'll look at in the next module. The non-allocating version uses an existing array, which I'm going to make in a moment, that lives in the script. It returns a number which is the number of colliders that were hit. And the reason it returns a number is so that you can use that number with the array that it puts the results in. So physics 2D, not 2C, 2D, there we go. Overlap box non-allocating. And you can see we need to put a bunch of parameters in now. So I need a point, I need a size, I need an angle, and then I need somewhere to put the results. So the point is my position. The size is my scale. The angle is rotation. It's the Z angle, because that's the only real rotation you use in 2D unless you're rotating away from the camera. And then I need somewhere to put the results. So I need an array. So I need to make one. So I'm going to make collider 2D array hit colliders. I'm going to initialize it as a new array with 5 elements in. So I can check a maximum of 5. And then I can just put hit colliders as the result. So what this will do is this will return however many colliders it hits up to a maximum of 5. And then what I can do is, having done that, I can check to see if that number is greater than 0. And if it is, do something with the results. So these results are dumped into the array, and this check just lets me know if I need to do anything with the results. Like, they'll still be there the next frame, but the number hit will be 0, so I won't do anything with them. So what I'm going to do is for int I equals 0, where I is less than numHit, I++. So now I want to check to see if any of the colliders are damageable. And if they are, break out of the loop and apply some damage to that object, and then just turn this projectile off. So I'm going to go if hit colliders I dot try get component damageable. Then if it is a damageable object, I'm going to damage the object. Now remember that damage returns a Boolean as to whether or not it destroyed the object. So I can go if damageable dot damage the function, and then pass in damage the amount. I've used the word damage a lot here, I realize. Then if that returns true, object was destroyed. So this gets called regardless. When you make a check using a function, the function executes and it just returns true or false because it has a Boolean return type. I don't have the other system set up to do anything with the object when it's destroyed, so I'm just going to leave that as it is for now. So if it found a damageable component, then an object was damaged, whether it was destroyed or not. So at this point, I want to play a sound effect, a hit clip with a scale of 1, and then I want to turn off this object. So what I need to do that is GameObject.setActive equals false. And then importantly, what I'm going to do is break out of this loop because I don't need to check any more colliders. I found one that's damageable, so I've turned off the projectile and I've broken out of the loop. I still need to advance the timer, so we're still in update here. So timer plus equals time.delta time. And then if the time is greater than the duration, then I also want to turn this off. GameObject setActive equals false, which means I missed and it's just flying off into space. So we can test that. So as soon as I start the game, what this should do is it should fire off. I am just going to set the audio clips. So shot and impact. Yeah, okay, so that works. Let's put an asteroid in front of it and see if it connects properly. Prefabs, asteroid, turn it on, move it in the way. There we go. There. So that works. Good. Right, so we will turn that script back on again. Going to delete that. So that means that the projectile is ready, so I can turn it off and create a prefab of it. Then I'm going to delete it from the scene. Then what I'm going to do is, because I want 2 different projectiles for each of the players, but I only want the thing that's different is the player number. So I'm just going to create a prefab variant. So there we go. I'm going to call this projectile 2 and then this one projectile 1. So if I change something about this projectile on the main prefab, it will be reflected on the variant. And the only thing that's going to be different is the player number. So I'm going to have player number 1 on that one and player number 0 on this one. And then I'm going to create 2 object pools. One for the first projectile and one for the second projectile. And then back in the game manager, I'm going to just create a reference to those projectile pools. So I don't need to do anything special with this. I can just have them publicly accessible. So object pool array, we call them projectile pools. Save that. And then to connect them up, I'm going to do the same thing as I did before. I'm going to select that. I'm going to lock it. I'm going to go back into the game manager. Add a second tab. And then just drag them across. Boop. Boop. Close that tab. Unlock the inspector and save. We won't know if that's working yet because there's nothing that can fire the projectile in the game right now. So that's what we're going to do next. So before I fire the weapon and use the projectile, which is different depending on which player fired it, I need to have a way of keeping track which players which. So I need to play a script, really. And that's what I'm going to do next. So I'm going to add a player script. I'm going to open that up, and what I'm going to do is I'm going to create 2 numbers. So I'm going to create a public static integer that is the total number of players. So remember, this is static, so this is going to be shared between all instances of this class. And then I'm going to create a public integer, which is this player number, but I'm going to use a property to make it publicly readable, but you can only set it from within this script, get private set. While I'm here, I'm going to create a value for the number of lives I have. Set it to 3. In awake, when this script is created for the first time, I'm going to set this player number to the current number of total players. So we'll give it an index. If it's the first player, it'll give it an index of 0. And then I'm going to increment the total players. which will be the same for everyone. So the next time this script is loaded, it'll do the exact same thing, except number will be 1, then 2, then 3, and so on. While I'm here, this would be a good place to put the collision detection for touching an asteroid. So I want to have it that if the player touches an asteroid, they die. It's a convenient place to put it here because I'm managing the lives here. So to do that, I'm going to give the player a damageable script. So I'm just going to do that first so I don't forget. I'm going to add damageable component to the player, then go back and create a reference to it. Damageable. Then in awake, I'm going to set it. Damageable equals get component damageable. And then I'm going to call a function when this object collides with another one. So void on collision enter 2D. Specifically, it must be 2D. This will not work. So it needs to be 2D. And then that gives me a reference to the collision, which will give me a reference to the object that I collided with. So all I need to do is check to see if that object is an asteroid. And I know that that object has an asteroid class on it. So even though I don't need to use the asteroid class, I can use that to see if what I touched was an asteroid. Another way to do this would be with tags. You could tag the asteroids and then check for the tag. Actually, that might be a more efficient way to do this, so let's do it that way. We're going to check with tags instead. So I'm going to add a tag. Asteroid. Right, so originally I was going to do this by checking for the asteroid script, but I don't need to use the asteroid script, so I don't need to check for it, not really. If I was getting some data from it, I might use it, and I might use try get component for that. However, I feel like this is going to be faster than using get component, so it's just generally a bit better way of doing it. So if collision, can I do it yet? No. Game object, compare tag, and then I want asteroid. If damageable damage, and I'm just going to give it a high number because I want it to definitely kill the player. Remember, this returns a Boolean. Then lives, minus, minus. And at this point, I will report the player has died. I can't do that yet because the function I need to do that with doesn't exist. But for now, that will work. Right, let's see if this works. Need an asteroid. There we go. Obviously the player doesn't come back, but it worked. The asteroids can now kill the player, so it's only fair that the player can destroy the asteroids. I'm going to do that with a weapon script that creates projectiles that then just fire off towards the asteroids. Right, so what is this script going to do? Well, it needs to know which player it is so that it can get one of the two pools of projectiles, and then it needs to enable it and just send it on its way, basically. So that's how it's going to work. So I'm going to create a player number integer, and I'm just going to, in start, I'm going to set this to whatever the player number is. So I'm going to get the player component, and get the number. only need to do this once. I'm doing it at start because I want this to be ready by the time I do it. And then it will just keep that for its lifetime. Next, I'm going to create an onFire script. So I need to call this onFire because if you remember the player container, the input component sends the onFire message. So all I need to do is create a function that's called onFire, and it will be called. It doesn't need to be public. It just needs to be called onFire in the same way that start or update or anything like that doesn't need to be public. It just needs to be called the right thing, and then it will be called as an event message. So what's going to happen in this script? I'm going to get the projectile from one of the two pools. I'm going to set it to the same position and orientation as the player, and then I'm just going to turn it on. So game object projectile equals game manager instance projectile. Oh no, wrong ones. Projectile pools. What's happening there? There we go. So there are two of these, and I need to choose which one I'm going to have. So I'm going to pass in the player number. And then call the get object function on that pool, which will get an object for me. And then going to do projectile transform position equals transform position plus an offset. So I need this to be created in front of the player, not on the player. So I'm going to create an offset that's controllable, which is going to be called offset, and it's going to be 0.75, so 3/4 of a unit. And then I'm going to just add, so I'm going to use the local up of the transform scaled by the offset. So that'll just be 3/4 of a unit in front of whichever way it happens to be facing. I say facing, it's up because it's 2D. And then I'm going to set the rotation to the same rotation. And then I'm just going to turn the projectile on. So set active, true. Save that. Go back to Unity. So this should work now. There shouldn't be anything else I need to do with this. Yep, that works. Let's find another asteroid. So we're getting to the point now where we're trying to finish up the player so we can turn it into a prefab and start managing the life cycle of the game. One of the last things I want to do with the player is make it so that it is invincible when it is respawned. So basically what this means is if it's been turned on, and it's not the first time it's been turned on, make it invincible for a little while and flash the sprite so you know it's invincible. So I'm going to do that with a special script. I'm just going to call it invincible on enable. I'm going to take all this out. So what do I need to put in here? So I need some controls at the top. So I need to control how long this effect lasts for. I need to control how quickly it flashes. I need a reference to the sprite that I'm going to flash on and off. And I need a reference to the damageable script so that I can turn it off so you don't take any damage while this is happening. So we put all those things in. Situation equals 3. Have 1/4 of a second for the flash interval. We need a reference to a sprite renderer. I'm just going to serialize field this and drag it. I'm not going to use get component this time. A reference to a damageable script. Okay, and I also need to know whether or not this is the first time it's been enabled. So first enable equals false. Actually, first enable equals true, because the first time this is turned on, it should be true. Okay, so in on enable, if first enable, we're going to set first enable to false, and then just return. And then if it's not false, if it's not true even, what we'll do here is start a coroutine. So I'm going to write the coroutine and then start it if it's not the first time this has been turned on. So I enumerator invincible. Did I type that correctly? Invincible, yeah. So damageable.enabled equals false, can't be damaged. Timer equals 0. So the reason I've got a timer here is because I need to measure how long we've been doing this for. I need 2 timers really, because I need one for how long we've been invincible for and one for how long the current state of the sprite is, so the quarter of a second that it's going to flash on and off for. So that's why there are 2 float timer values. And then visible, we're going to start with false. And then while timer is less than duration if interval is greater than the flash interval, we need to change the state of the sprite. So sprite renderer dot enabled equals visible, and then change visible to the opposite of visible, and then reset the interval. Now, one way you might reset an interval is by doing that, setting it to 0. However, especially when you've got shorter amounts of time, it's actually more accurate to subtract the interval value from the timer. So that needs to be flash interval, not interval. And the reason this is because it takes into account any time that's progressed during this frame. So you're never going to hit it exactly on. You're going to go over by an amount. And if you just subtract this amount from the interval, then you keep that remainder, and it just keeps it that little bit more consistent. Functions like invoke repeating do this by default, but when you're measuring time yourself, you just need to be mindful of it. So when this isn't true, interval plus equals time delta time, timer plus equals time delta time, yield return null. And when this finishes, so when the invincibility period is over, we're going to change the sprite renderer enabled to true, and damageable enabled equals true. Now, something I want to do, just in case the object gets disabled while it's doing this, is I want to set those to reset them basically if the object's turned off. It shouldn't be turned off because it can't be destroyed, but knowing that turning the object off could interrupt this process, I just want to put those in on disabled as well. So the last thing I need to do is start the coroutine. Start coroutine invincible. Right, so I need the display and I need damageable. Okay, now it should work. Off and on. There we go. And what I can just do, just to make it a bit easier to get to an object, I'm going to give it a 20-second duration. Turn it off, turn it on. Right, I'm invincible. Let's find a rock. Pachow. Yep, no, nothing. Can't hurt me. There we go. So that's working as expected. Right, so now that the player can be re-enabled, I need to have a way of respawning it. So I'm going to go back into the game manager. I'm going to add some functions to allow a player to report its own death and for the game manager to respawn it when that happens. I'm going to need to add up at the top a serialized float. That is the respawn duration, just because I want to be able to control how quickly this happens. I'm going to set it to 2 seconds. And then just at the bottom here, I'm going to add a public function called report player death. Now, when a player reports its death, it's going to have to give the game manager some information. It's not enough just to say a player has died. It wants to know which player, possibly pass a reference to it and tell it how many lives it's got left. So what we're going to do is give it a game object reference player. So which object are we talking about? We need this so we can turn it off, turn it back on again. The player number, which we'll need to change the amount of lives that are displayed when we do that later, and the lives that are left, which the player knows but the game manager doesn't. So at this point I will update the UI, but I don't have a function to do that yet. So if lives are greater than 0, then the player is still alive and it needs to be re-enabled. So I'm going to put this in a coroutine. So I enumerator re-enable player, and then I'm going to take a reference to what player we're talking about. Yield return new, wait for seconds, respawn duration, and then player dot transform dot position equals vector3 0. So I'm just going to put it in the middle, and then player set active true. Okay, so if the lives are not run out, start the re-enable player coroutine, pass in the player we're talking about, and then return out the function. Don't do anything else. But what if we don't have enough lives? So if lives equals 0, could do less than or equal to 0, although shouldn't be an issue. Player total players, so this is the static reference to the total number of players. Reduce the player number, and then if player.total players equals 0, then the game is over. and this will no longer be true, and it'll move into the end game state. Save that. And I then need to go into the player script to report the death. So where the player has died, I'm now going to do game manager.instance.report player death, and the game object is this object. The player number is number, and lives is lives. So let's see if this works. Need some asteroids. So what I'm looking for is it to respawn and then stop respawning once I run out of lives. So although you can't see the amount of lives I've got left, I should have 1 left. I shouldn't come back now. And I don't. Okay, good, that's working. Okay, now that we're starting to get to the point now where it's all coming together, so I need to start connecting some of these systems up and having them talk to each other. So we've got these UI elements here, and I want to give them the ability to update when something happens. So I'm going to go on to their object. They're just on a canvas object. So there are 2 of them. I'm just going to select them both, and I'm just going to add a new script called player UI. Now I'm going to be using UI classes in this, so I need to add Unity engine.ui, and I'm going to get rid of this. So I need a reference for a text object for the lives display, because it's just a text object. And I need another one for the score display. I also want to be able to set the color of this. So I'm going to do that function now. I'm going to create a set color function. So set player color. It's going to take a color, which is the player color. God, I don't like spelling it without a U, but I'm going to be consistent. So lives display dot color equals player color, and then score display dot color equals player color. And when there is a color to give to this, it will mean that the ship and its score will be the same color. Right, so now I'm going to update the lives. So I'm going to create a public function called update lives. Int lives. Now, this measures one thing and has multiple outcomes. Which is a good use case for a switch statement. So I'm going to do switch measure lives, and then I'm going to do case 3. So if there are 3 lives, lives display dot text equals, and then I'm just going to do, because that's what I've put in, and then break. I'm going to do this 2 more times. So 2 lives, 1 life, and then default is don't show anything. And then I'm going to go back into the game manager, where I need to create an array of player UI elements, so 1 for each player. So I'm just going to go serialized field, player UI. That's not how you spell UI. There we go. Player UI. And then I'm going to select the game manager and just drag those two. So now I've got two UI elements. That's why. So in the report player death function, I need to do player UI, pass in the player number to get the correct one. Update lives. So I need to connect the score. Ship. There we go. Okay, there we go. So that now works. Come back. Yep. Good. Okay. So now I want to display the score as well. So while I'm here, I'm going to create a function to update the score, and I'm going to go back into the player UI script to do that. So I'm just select it from here. So I've got a reference to the score display, which I've got a placeholder here, which is 6 digits. And I'd like to keep it as 6 digits and then just update the number, as opposed to having it as, say having it as like 1, like that, or 50. I want to have a bunch of zeros and then 50. So how did I have 6? There we go. So here's how I'm going to do that. I'm going to have a public void update score function that's going to take a score value, and then I'm going to do score display.text equals string.format. So what this does is it takes an argument, which is argument 0, and it will place it in a particular format. So you can do, here is argument 0, and then the format that I'm going to put it into, you can see these are all the other formats, is a 1, 2, 3, 4, 5, 6-digit number. And then the number that I'm actually going to pass into that is score. Oh, I missed a bracket. There we go. So now I need to call this from the game manager. So I'm going to go back to that. So I'm going to create a set of scores here. So I'm going to create it's an array of scores equals new int. So it's 2 scores. And then I'm going to create a public void function called update score. Now this needs to know 2 things. It needs to know how many points to add to the score, and it needs to know which player gets the points. So I need int points to add, and then int player number. So scores, so which, remember there are 2, so which one are we talking about? We're talking about whichever player number plus equal points to add, and then player UI, which UI are we talking about? Again, the one that matches this player number. Update score, scores, player number. Now the last place I need to do something with this is where the actual scores are added, which is in the projectile script. So if the object was destroyed, so in the projectile script, if the object was destroyed, I need to check to see if it is an asteroid and get its points from it. So I'm going to do if. I'm just going to copy this and change it. Hit colliders. Try get component out. Asteroid. Asteroid. And then game manager dot instance dot update score asteroid dot points value, and then player number, because this projectile knows which player fired it. Save that. There we go, we have score. So bigger objects are worth more points. Smaller ones are worth less. Right, that is working. So now that that's working, I want to make sure that if I add 2 players, that this is going to work. Now, the good thing about this system is that I've got 2 controllers connected. I should technically just be able to duplicate the player and it should just work. So let's see if it does. So I've got 1 player. I've got 2 players. So here's 1. Pick up my other controller. Here's 2. So we're going to check if the lives and score displays are working. So player 2 is scoring points. Player 1 is scoring points. Do they both lose lives correctly? Yes, they do. There we go. And what that means is that the player is now ready to become a prefab. So I'm just going to drag that in and then remove it from the scene. Save. And now we can spawn those players to create the game loop. So we're nearly there. Now I want to spawn the players or player, give them their color their menus, and set up the game. So I'm going to go back into the game manager. I need to add some more information to this. So what do we need? Well, we need to know if it's a 2-player game. I'm going to have this as true, as default. We need a value to offset the 2 players when they're first spawned. So I'm just going to have that as position offset and set it to 3 units. We need a reference to the prefab that will be the player object, and we need an array of colors. These will be the player colors we'll use to color the players and the menus. So now I'm going to go into the part of the coroutine where I set up the players. So I'm going to set total players to 0, just in case it's not. Then I'm going to decide how many players are going to be in this game. So here, I'm going to return one of 2 values based on another condition. So the condition is if it's a 2-player game, and if it is, I want to return 2 players. If it isn't, I want to return 1. So that's the sort of thing I'd use the ternary operator for, because it's just easier that way. So to use the ternary operator, you set the thing you want to set, and then you start typing the condition. So 2-player game. Obviously, this is causing an error right now because it's like you can't set an integer to a Boolean. But as soon as you do the question mark, it now knows you're using the ternary operator. So based on this condition, I want to return the first one if it's true, 2, colon, or the second one if it's false, 1. So number of players will either be 2 or 1, depending on if it's a 2-player game. And then I'm going to iterate through either 1 player or 2 players. So for int I equals 0, where I is less than number of players. So this may only do this once if it's a 1-player game, but it means I don't have to write it twice. And I can put everything in one place. So game object player equals instantiate player object. Now, if it's a 2-player game, then I want to position these apart from each other. So I'm going to create an offset, and I'm going to use the ternary operator again here because I want to create a positive offset if it's the second player and a negative offset if it's the first player. So the first player will be on the left, 3 units left of origin, and the second player will be on the right, 3 units right of origin. So knowing I only have 2 players in this game, I'm just going to do that once by checking if float x offset, so I'm going to set it in this value, equals, so I'm going to put my condition in here. So is I equal to 0, and again errors until I use question mark. If it is equal to 0, minus position offset. If it's not, then it's the second player. Position offset is just the positive one. So this will either be -3 or 3. And then player transform position equals vector 3 right times x offset. So this will be, remember vector 3 right is 1, 0, 0. So the position will either be 3, 0, 0 or -3, 0, 0. But only if it's a 2-player game. If it's a 1-player game, all I want to do is put the player in the middle. So I'm just going to do player.transform.position equals vector 3, 0. So what's next? So now I need to set the display of the object. So I know that the first sprite renderer on the object is the one that I want to set. So I can, where's my player? In the prefab. So this is the display that I want to set. So I know that I can just get the first one. So I don't need to have a reference for it in here. I can just get it once and set it once and that will work. So I'm going to do player, get component in children, sprite renderer, dot color equals player colors. Now remember that's an array of 2 colors, and I need to pass in either 0 or 1 depending on which player it is. And we're going to pass in I because that's how we're iterating through the players. Then player UI I dot set player color, player colors, and then player UI I again, game object dot set active true. So this is going to enable the player UI when the player is set up. So what I need to do is I need to go in, I need to turn the UI off. So player 1 off, player 2 off. I also need to choose some colors. So game manager, player colors, going to make 2 colors. Going to make blue yellow. Do I want yellow? No, I want kind of pinky red. There we go. And one last thing I need to do is I need to set the player object to the player container. Right, so this should all work now. Now, I'm going to hit play and something's not going to work, but I know that it's not going to work this time. So tell me what's wrong with this picture. Yeah, can't see anything. So when you create a new color, and you'd be surprised how easy this is, it's transparent by default. So you need to put up the alpha as well, and then this will work. Here we go. Now we have 2 players. Starting to look like a game. Okay, so there's one last thing that I want to do, and that's that I want to enable one of these 2 win screens if one of the players wins. So you can see that they're like this, and they're going to adopt the color of whichever player wins. So I'm going to go back into the game manager for the last time, and I need to create a reference to those win screens. And again, I'm going to do it as an array so that I can pass in a player number and just get the one that I want. So I'm going to put it underneath here. Serialize field. Just going to do them as game objects because I just need to turn them on or off. I don't need to do anything special with them. Win screens. And then in the end the game section of the coroutine, if it's a 2-player game, we need to work out who won and then show their screen. So an easy way to check for the highest thing in a list is you just keep a track of whichever one was the highest and check everything and replace it if it beats it. So for example, go int highest score equals 0, int winning player equals 0, and then for int I equals 0, where I is less than number of players, I++, if scores I is greater than the highest score, then highest score equals scores I, and the winning player equals I. Then win screens, winning player dot get component Unity engine dot UI, because I don't believe I have this namespace added, so I'm just going to do it here. Image dot color equals player colors, whichever one the winning player color is. And then I'm going to set the winning player win screen set active equals true. So this is only going to happen if it's a 2-player game. Regardless, it is going to wait for 5 seconds, and then it's going to reload the scene. So I am just going to add this namespace because otherwise it's a bit fiddly. So using Unity engine .scene management. Where was I? I'm going to go scene manager, load scene, scene manager dot get active scene dot name, and save. And and then I just need to connect up those objects. So back in here, I need the player 1 win screen and the player 2 win screen. Get on there, you. There we go. And now I'm ready to test it to see if it works. So let's have player 2 win the game. So I'm just going to make sure that they've got more points, and then get rid of the other players. So last life, and it should show nice pink windscreen. There we go. And it reloads and restarts. So hopefully you found this longer lesson useful, and it's helped to show the lessons that you've learned in this module in context. If you're struggling with anything, or if you still have questions, please speak to me directly in the course Discord or ask the other members there, and either them or I will be happy to help you. If not, if you feel like you understood most, or if not all of what I've just covered in that module, then you're ready for the next module. You can move on to module 2, advanced scripting and solving problems with code.